In this video, I'll demonstrate how to read the textbook with the help of the reading guide. I'll go through piece by piece the reading guide for section 2.1 on rates of change and tangents to curves. Now, I know you're all college students, you have a lot of demands on your time, but I think you'll find getting into the habit of reading the textbook is a good idea, and it will lead to greater success in the course. Even though you'll put a lot of time into reading the text up front, it will save you time later on as you work through the homework problems and do the in-class work. Most sections of the textbook are only 5 to 6 pages long, but that doesn't mean it's only going to take 10 minutes to read them. Reading math text is different than reading for many of your other courses. It's a slow process, so you need to set aside a block of time that you can devote to reading the section. You'll want to eliminate distractions and have paper and pencil with you so you can go through calculations on your own. The reading guide begins with a set of learning objectives. For section 2.1, there are 6 of them. And as an example, you see the first objective is to state the definition of average rate of change. So you'll want to skim through these, knowing that some of the terminology and concepts will be unfamiliar to you at this time. That's perfectly fine. You can revisit them later once you're more familiar with the material. The next section of the reading guide is called Preparation, and it describes what you need to do before coming to class. In general, you'll need to read the section and watch the corresponding videos. There may be additional items. For section 2.1, you also need to know the definition of average rate of change, and you need to know how average rate of change and the slope of the secant line are connected. If you look at paragraph 1 of the reading guide, you're asked to read the passage average and instantaneous speed. Now it's important that you pick out the main ideas from this passage. The main ideas I picked out were Galileo's formula for the distance traveled by a falling object and how to compute average speed. Next, you should read through examples 1 and 2. Once you've read them, there are a couple of things for you to do. The reading guide says to check at least 2 of the entries in table 2.1. What we're doing is computing average speed over the interval t0 to t0 plus h. And if you look at the table, the first column gives us different values of h, starting with h equal to 1. The second column looks at an initial starting time of 1, t0 equal to 1. So let's do the calculation for these two values. Delta y over delta t equals 16 times the quantity. I'll replace t0 with 1, replace h with 1, minus 16 times t0 squared, all over h. Okay, so we have 16 times 2 squared minus 16, which is 64 minus 16, 48. And the units here would be the units of y, feet, divided by the units of t, seconds, 48 feet per second. If we compute another entry of the table, let's do the entry for h equal to 1/10, again with t naught equal to 1, the computation looks like this. Delta y over delta t equals 16 times the quantity t naught 1 plus h 1/10 squared minus 16 times t naught squared all over h 1/10. Okay, and so this reduces to 19.36 minus 16 over 1/10. 33.6, and again the units would be feet per second. So you could certainly check other entries of the table if you'd like, but this is at least how you would check 2 of them. The next action item is to work through the algebra at the top of the page following the table. So I'll illustrate how to do this. And we're going to set t naught equal to 2 and do the algebra. So we have delta y over delta t equals 16 times the quantity 2 plus h squared minus 16 times 2 squared all over h. Okay, I'll multiply out 2 plus h quantity squared. We'd have 16 times 4 plus 4h plus h squared minus 16 times 4 is 64 all over h. Okay, the next step is to distribute this 16. So I will start a new line. We'd have 64, that's 16 times 4, plus 64h, that was the 16 times 4h, plus 16h squared, that was the 16 times h squared, minus 64, all over h. And notice 64 minus 64 is 0. And what remains in the numerator, we can factor out an h. We'd be left with h times 64 plus 16h all over h. And of course, this is the desired result, 64 plus 16h. The last action item is to answer the question, how does the formula relate to table 2.1? This is the average speed over the interval 2 to 2 plus h. Okay, and that means if h is equal to 1, for example, we're computing the average speed over the interval 2 to 3, and we use the formula 64 plus 16h. In this case would be 64 plus 16 times 1, 80 feet per second. And so this formula is giving us the entries in the third column of the table. Moving to paragraph 2 of the reading guide, it says to read the passage average rates of change and secant lines. Again, I'll ask, were you able to pick out the main ideas? One is that average rate of change is defined for us. And this is a definition you need to memorize. The other main idea is that the average rate of change is the slope of the secant line. Read passage called Defining the Slope of a Curve. Try to pick out the main ideas. Tangency is defined for general curves. And it might be a good idea to draw a picture similar to what you see in figure 2.3. Okay, this is giving us the geometric idea for the tangent to a curve. So let's just suppose our curve looks something like this. And we're interested in tangency at this point P. So what we'll do is we'll look at a nearby point on the curve, call it Q. We'll form the secant line, the line through these 2 points. And then we'll allow Q to move along the curve towards our point P. So let me draw Q moving to this point right here. Form the secant line, and we'll continue letting Q move closer and closer to P and look at the limiting position of these secant lines. That limiting position is what we define to be the tangent line. We'll read example 3 next, and hopefully you see the parallels between this example and the previous example. In example 2, we computed average speed over shorter and shorter intervals. In example 3, we're computing the slope of the secant line over shorter and shorter intervals. Figure 2.4 is important. You're asked to look at each labeled item and ask yourself, why is each item labeled? What is the role of each item? So let me try to illustrate that. I have copied here the figure. We're interested in determining the tangent line to this curve at the point P. The first labeled item that I would point out is this delta x. Our small change in x, we'll call it h. And the next item is the secant line through the point P and nearby point Q. Now you all know how to compute the slope of this secant line. It's change in y over change in x. So we'd have 2 plus h quantity squared minus 4 over, technically here in the denominator, I could write 2 plus h minus 2, which is simply h. And when you do the algebra, you see that the slope of the secant line is h plus 4. Okay. Now we're going to let this point Q move along the curve toward our point P. And what's happening as we do that is this change in x, h, is getting smaller and smaller. In fact, we're letting h approach 0. So what happens to this quantity h plus 4 as h goes to 0? Well, it's going to approach 4. And that's the slope then of our tangent line. Continuing with paragraph 3, you should read the passage Instantaneous Rates of Change and Tangent Lines. Try to pick out the main ideas. Here it's that the instantaneous rate of change is the slope of the tangent line. Read example 4. You might ask yourself, do I understand the calculation that takes place, and do the units make sense? If you think about the units, remember we're computing the average rate of change, delta P over delta T, where P is the population of fruit flies, So we'd look at the units of P over the units of T, time. So we're left with flies per day for our units. Now you're also asked, what does the average rate of change mean in this context? And would you be able to explain it to your group? So here's one interpretation. If the number of flies changes at the rate of 8.6 flies per day, then from day 23 to day 45, the number of flies increases from 150 to 340. The last item is to read example 5. There's a few questions you should answer. One is, how are the table entries and the graph related? Well, each entry in the table gives the slope of the secant line illustrated in the graph. The other question is, what is the relationship between the slope of the tangent and the answer to the question posed in this example? It turns out the slope of the tangent line answers the question. It tells us how fast the number of flies in the population was increasing on day 23. And so we've finished the reading guide. Hopefully this is illustrated for you exactly how that process works.